So now that I have NAT working statically over here, we're going to do something that's a lot more useful for configuring NAT on this side. So what we're going to do is we're going to set up NAT on this router to hide the LAN, the local area network, to hide these private addressed computers, the 192.168.1 network, and we're going to hide it behind this NAT right here. And since we have multiple computers here and we have only one public IP address, the 200.10.0.1 address, right? This is our inside local over here, and this is our inside global address right here. So what we're going to do is we're going to set up NAT overload on this router. So on this router, I'm going to hit enter, and this will be like a port address translation that will enable all of the private computers on the network to adopt the public IP address of the router, right? So everybody will translate to the one address. I'll do a conf t to get to the global config mode, and to do this, what I'm going to do is I'm going to write first of all an access list. So access dash list 1. So it's going to be a standard access list, and we're going to permit the 192.168.1.0 network, and we got to put wildcard bits for it. Let me spread this out so you can see it. So 0.0.0.255. So that's wildcard bits, which is the opposite basically of a subnet mask. So the subnet mask would be 255.255.255.0. So the wildcard bits is the exact opposite of that. So that's going to set up an access list, all right, permitting the 192.168.1 network, and that's these private addresses over here. Now I can do my NAT statement. So IP NAT inside source, and for the source addresses we're going to use list 1, which means access list 1, right? Access list 1 will be our source addresses, right? And then for the public IP address that we're going to NAT to for our outside address, we're going to use interface, whatever the IP address is on interface serial 2/0, and we're going to overload it. So we're going to do port address translation. So all private computers on source on access list 1 will be translated to the IP address on interface serial 2/0, and we'll need port assignments to do it. So I'll hit enter, all right, and that's done. Now all I have to do is tell NAT where the inside of our network is and where the outside is. So interface serial 2/0, right? That takes me into interface configuration mode, and IP NAT outside. That's the outside of our network, and then interface FA 0/0 takes us into the interface for fast Ethernet 0, and that's going to be IP NAT inside. All right, and so that's all done. Now normally what you'd want to do is you Control C, go back to privileged exec mode, and do a copy run start, which is short for copy running -config space startup -config, right? And that would save your configuration file. So now that we have that set up, NAT should be working. So these private addresses should translate to this public IP address. Now the way to test that out is to go into simulation mode, right? And simulate sending packets across the network. So what I'm going to do is I'm going to say auto capture, and then I'm going to go to PC0, and I'll go to command prompt, and I will ping the server on the other side of the network. So that's, let's say, 200.0. As far as I'm concerned, it's 200.10.0.2, and I'll hit ping, right? And so now these packets are going across. See it? There it goes. Packets going across, right? There it goes. And when it goes across here, I'm going to click on it and capture it. All right. And so there it is. I've captured it. And you can see here that the inbound PDU details, you can see here that the source IP address was 200.10.0.1, destination IP address 200.10.0.2. So sure enough, the 192.168.1.100 address, right? The original source IP address from where the ping was generated, right here on this PC, has been changed or translated to the public IP address of the router interface right here, right? And so it worked, and we could see it by just examining the packets.